Okay, and this next to the last section, we're going to graph inequalities, right? So an inequality is where the equal sign has been replaced with a less than or a greater than, less than or equal, greater than or equal, right? This is a less than or equal. This is a strictly less than. Our first step in graphing these inequalities, let's start with this one because this is x plus 2y is less than or equal 6. So the x plus 2y equals 6 is part of my actual answer, right? X plus 2y equals 6. So the first thing I'm going to do is I'm just going to solve this equation. This is a linear equation. Let me get our axes going over here. We didn't actually graph linear equations in this section unless you went back and did review, but that's the thing we said. You better know how to graph a linear equation and a linear function and solve a linear equation, right? This will be a linear function because we've got an x and a y. And I know because it's x to the 1, y to the 1, it makes a straight line. I just need 2 points. So a lot of us solve these things for y and do the slope intercept. The best method on this one is just to do your intercept method, right, where you get the 2 intercepts. If x is 0, y is 3. If y is 0, x is 6. And you quickly get 2 points. All right, so I'm going to plot these 2 points. If you need help or a review with just the graphing the specific linear equations, let me know. Do something because you got to know that. Okay, so 0, 3, and then 6, 0. We'll just extend it over here. Now, I'm going to draw in the line because the line is actually part of my solution. Remember what that means? Every point on this line is a solution to this equation, and I want the ones that's either less than this equation or equal to. So equal to is right here. Okay, so that's half of my answer. The other half is the less than part. Okay, now if this is where it's equal, the only thing that can happen on one side of where things are equal, on one side it's less than being equal then, and then on the other side it's more than, right? If it was just a straight number line and we only had to talk about one value, if this is 3, well, everything over here is less than 3. Everything over there is greater than 3. Because I've got a combination of two things, it's sometimes not so obvious which side is less than or which side is greater than. So instead, what I'm going to do is I'm going to pick a point, right? Some point on a line, any point, not on the line, some point on the graph, any point, and if my graph doesn't go through this point 0, 0, that is by far the easiest thing to check. That just means this is the point where x is 0 and y is 0. So if I plug that in my graph up here, in my equation up here, my inequality, then 0 plus 0, see how easy that makes my math, is less than 6. I want to know if that's true. Is 0 less than 6? Yes, it is. That means that's part of my answer. That means everything on this side of the graph is part of my answer, and we will shade it. Okay? On your homework, you're going to have a little bucket you select, and you just click the side that you want to shade, and it'll automatically shade it. On the test, on the paper test, draw lines through it and indicate that that's your answer. And that's it. That's all there is to it. Let's try this one now. It's still a line, right? Because my x and my y both just have an exponent of 1. So I know it's a line. It's not quite set up any nice way for me to solve it. But remember, my first thought is, when I'm doing inequalities, is I do want to actually know where the line is. Now this one doesn't say or equal, so the actual line's not going to be part of my solution, but it's still going to be the boundary. It's going to go all the way up to where it's equal. Just don't count the part that's equal. So instead of a solid line, we indicate that by a dotted line, but it's still going to be our boundary. I still want to solve this for the line 5x equals 4y minus 2. Okay, so to do that on this one, okay, I'm going to flip that around because I probably will use the slope-intercept method on this one, meaning I'm going to solve this thing for y. So let's add 2 to both sides. And then divide everything by 4. Okay, so that means my y-intercept is at 1/2. 2/4 is the same thing as 1/2. And I've got a slope of 5/4. Up 5, 1, 2, 3, 4, 5, and over 4, 1, 2, 3, 4. Or I could have went down 5, 1, 2, 3, 4, 5, and backwards 4, 1, 2, 3, 4. Either way, I get a line here, right? But don't draw a solid line through it because it doesn't say or equal. That's the difference. This one said equal, so the line was part of the answer. This one does not, so the line is only the boundary, but don't include the actual points on the line, and we represent that with a dotted line. Okay, then after that, I need to see which side to shade, which side is my actual total answer here. Since it does not go through this point 0, 0, I'm going to plug that in up here and ask myself, is 0 less than 0 minus 2 is minus 2. Is 0 less than negative 2? No, 0 is not less than negative. That's not my answer. That means I'm going to shade the other side. Right? Okay. Okay. Here's some more, but they're not lines. This is a parabola. This one's a circle. All right? But it works the same way. The first thing I'm going to actually do is think about graphing where it equals x plus 1 squared plus 2. Okay, so I got to remember how to graph a parabola. And this one, the way it's set up, I can use my translation. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, okay, 2, 4. Get those really quickly. And then I'm going to move every one of those points left 1 and up 2. So left 1 and up 2. 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 Okay? Now, do I draw a solid line or a dotted line to connect those dots? It does not have the equal sign as part of the problem, so it is a dotted line. Now, I want to know if I'm going to shade in here or out here. Let's pick a point. The point 0, 0 is the handiest one to pick. Because look what happens if we plug a 0, 0 in. It says, is 0 bigger than 0 plus 1 is 1. So is 0 bigger than 1 plus 2? Nope, it is not. So that means I need to shade inside my parabola. Not these points, but everything inside this boundary will solve this inequality. Okay? This next one is a circle. So what do we need to graph a circle? Yeah, the center and the radius. So the center is 0, -1, right? -1. And the radius is the square root of 9, 3. Now, 0, -1 is the center. And so 3 units in each direction is an actual point on my circle. So now all I have to do is draw the circle. My only question is, do I make it a solid line or dotted? It is indeed solid because it has the equal to part. Okay. Circular, sort of. All right. Now what? Oh yeah, don't forget to shade, right? So because it's an inequality, I got to think about shading. I'm going to pick this point. As long as my graph isn't on that point, I can pick it. So my question is 0 plus 0 plus 1 is 1. Is 0 plus 1, is that less than 9? It definitely is. So that means that's part of my answer. That means we're shading inside the circle versus outside the circle. Okay, now we have a system of equations. So it's gonna, the exact same thing is gonna apply that we were just doing, except we'll just graph this and this on the same coordinate system. Before, on those previous problems, we had a problem over here and then a separate problem over here, right? And I did them individually. Now, if I have a system, I've got to consider them at the same time, simultaneously. Okay? So, for this one, it's a linear equation. Once again, a linear inequality, but I'm going to make it a linear equation. Once again, it's not really set up nicely for any method. So I'm going to add 2y to both sides. My first thought was I was going to do that and solve it for y, but hey, once I get to this point, I realized the intercept method would work wonderfully. So if y is 0, be careful about your order here now. If y is 0, x is 6. Okay, and if x is 0, y is 3. So I've got those points, 0, 3, and 1, 2, 3, 4, 5, 6, 0. Okay, dotted line. And then figure out which side to shade. Let's plug in 0, 0. So is 0 bigger than 6? No, I'm going to shade this side. Okay, now I'm just going to do this other one. Hey, this is a quadratic equation. So again, I'm going to turn that around, but make sure you keep the big side pointed to the 2y. Turn it around so that it looks normal, right? Big side pointed to the 2y. And then I'm going to divide by 2. And I'm really trying to solve this equation. Okay, it's a parabola. So I've got those same basic points that I can get very quickly. But as I'm plotting them, I'm going to take half of the y value, remember? Remember our transformations. So my y is at 4, so half of that is 2. Half of 1 is 1/2. Half of 0 stays 0. And then half of that, half of 1 is 1/2, half of 4 is 2. Dotted line. All right. I cannot use the point 0, 0 on this one because my graph actually goes through that point. So maybe I'm going to use the point 1, 1. You can use any point you want. You could use, if you wanted to use 1, 0, but if you use numbers like 0, 0, 1, 1, 2, 2, can't use 2, 2 either on this one, no. I don't have to be too careful or worry about mixing up my plugging in the wrong X and Y value, right? So I look for those points, but you can use any point you want. So I'm going to use 1, 1. That means 1 squared. I want to know, is that less than 2? Is 1 less than 2? Yes, it is. So I'm going to shade inside the parabola. Now, I got to go back and decide. So when you're doing your homework, you should graph these. By the way, I'll just make a mention about graphing on your homework. A lot of times it's multiple choice. You should always graph them by hand or you will not be able to do it on the exam. So graph these and then decide, and you can't click the different ones and see where it overlaps. Once you click it, it's just going to shade that side. So you have to know before you fill in where you're going to shade. And then on the exam, you're going to go in and you're not going to leave it like this. You're going to make it obvious. Oh, I only want, because it's a system, it's got to satisfy both of them at the same time. So I only want this overlap and shading. It's this part is my answer. Okay, make that obvious on the test, what you've chosen your answer to be. Okay. Now we've got an absolute value and a linear. But the linear one's really easy, right? It's either a horizontal or a vertical line. I hope we know which one. Okay, if y is less than 0, that's a horizontal line. And really, I'm just doing the y equals 0 part, right? And this is where y equals 0. And it's going to be a solid line. So I just get to go through my axis with a solid line. And these kind of pretty easy because less than 0, I know it's down here. I don't have that confusion of an X and a Y that tilts and I'm not sure which side. This is just a number line. I know this part down here is what's less than Y. You can still pick a point, plug in a point, not 0, 0, right? But you could plug in 1, 1 and you'd get, hey, is 1 less than 0? No. So don't shade this side, shade the other side. Now we've got absolute value, so we should be able to do those points very quickly to do our transformations. And I'm going to take every one of those points and move it up 1. Up 1, up 1, up 1, up 1, up 1. And I know it's a V shape. It is going to be a solid line again because it has that equal part. Okay, and I'm going to ask myself, I'm going to pick this point right here, 0, 0. So is 0 bigger than 0 plus 1, 1? Is 0 bigger than 1? No. So don't shade outside, shade inside the absolute value bars. And then when I try to see, well, where's the overlap? Notice there's not any overlap. Right? If there's not any overlap, then there's nowhere that, no values I could pick that would satisfy both of the equations at the same time. Okay, last two, I believe. All right. So here we've got two parabolas. That first one, if I'm not good at my factoring, I might think I have to use that second method, that we talked about when I couldn't use transformations, where we use negative b over 2a for the x coordinate of the vertex, and then plugged in, found our x-intercepts, y-intercepts. Or I can recognize that because of factoring, because I'm good at factoring, or I want to be good at factoring, I try to be good at factoring, that's a perfect square trinomial and it factors like that. Okay, so these are both parabolas. I need my basic points, my actual basic points. Okay, and on that top one, I'm just going to move every point left 2. Solid line. Okay, let's pick this point. If I plug a 0 in here, and a 0, 0, 4, is 0 bigger than 4? No, don't shade that. Shade inside the parabola. All right. This one is just the reflection. So I'm going to make my y values negative. I already have my basic points plotted. So y values are negative. This one's going to be a dotted line because it doesn't have the equal sign, right? So that's all that tells me that. I can't use 0, 0 for my point, so let's use 1, 1. So if I plugged a 1 in here, I want to know, is that less than, remember this negative? Nothing to do with that, so is that less than negative 1? Is 1 less than negative 1? No. 1 is not so don't shade outside. Once again, I would be shading inside. So what's my solution to this system? The overlap of the shading. Absolutely right. No solution. Notice in this one we've got 3 equations. Now once you get more than 2, you could have 3 or 4. You need to start keeping up with your answer solution as you go along, because you got a bunch of stuff on your graph and lines everywhere. At the end, it's like, oh, where are they all overlapping? I don't know. So kind of keep up with your answer bit as you go along. Okay, so this first one again, these first 2 actually, are just horizontal and vertical lines because all you have is an X and a Y. So when X is, now these are going to be dotted. So when X is negative 2, and 3, and then you have that X is in between there, right? So that's all of this bit in between negative 2 and 3. Okay, now this one involves Y. We've got, I'm going to have solid lines here. Negative 1 and 5. Okay, and we're in between negative 1 and 5. So far, if those were my only 2 problems, my answer would be this rectangular region, and I would shade it in solid, right? Shade it in solid. Okay, but I've got another one to consider. So this one's set up perfectly for the intercept method. If x is 0, y is 6. If x is 0, y is, that was 5, so here's 6. And if y is 0, x is 3. Dotted line. So I'm going to draw a dotted line through. I'm going to pick the point 0, 0. Is 0 less than 6? Yes. So I'm going to shade the section that has this point in it, which is this side of the line. So notice how much stuff we have going on, but because I've kind of kept up with what's going on, I know that my answer a while ago was this rectangular region. So now that part's not part of it. So I'm going to shade in right here. Okay. All right, following those lines. It's my border. This one's my border. Don't make it solid. Don't make that a solid line. Just shade in solid. Okay, and anything in this region, okay, will solve all three of these inequalities. Okay, guys, one section left to go. It's a real short, sweet, simple section, so I'll see you for that.